Hi, welcome back. We're going to start with the chapter 2, atomic structure. In this atomic structure, there are three subtopics, 2.1, 2.2, and 2.3. These are the objectives under C1 and C2, which we'll emphasize in lecture. These four objectives are fall under C3 and C4. Because of this, 2.1 is considered a new topic for you, so I will briefly go through all these objectives based on the tutorial questions. Okay, let's start with tutorial question number 1. State the four postulates used by Bohr to explain the nature of an atom. So I believe that you heard Bohr before, especially during your time in Form 4. While postulate is another new term for you. Okay, so a general easy to understand term for postulate can be considered as assumption. So in Bahasa, we call it as anggapan. However, this assumption will be more scientific based if we use the term postulate. Okay, let's look at the first postulate. Electron will circulate around the nucleus in certain orbits or energy levels or shells. So we consider these three terms, orbit, energy level, and shell. They refer to the same meaning, in which in Bahasa we call it petala. Okay. So let's say in the middle here, the blue color, this one is the nucleus. So and then if I have the electron, so means that the electron will always moving circulate. Okay. In certain orbit or energy level. Means that the electron will not move in between two energy level. Okay. They will always just move in the orbit. Okay, so this is incorrect. The electron will not in between two shell. Okay, so second postulate say that only orbit with definite energy are permitted for electrons. So means that each electron will going to have definite here, have the meaning of fixed. Okay, how the energy of the electron will be fixed, because we have one formula here, En equal to negative RH 1 over n square. So the n here is represent the shell, orbit, or energy level. Okay, the n here is not number of mole, but is referred to orbit, energy levels, or shell. So means that if I ask you to determine the energy of the electron at second shell, so you are going to use this formula. Okay, the n will equal to, at where the n will equal to 2. Okay, if I ask you what is the energy of the electron when it is at the second shell. Okay, so what is the RH? RH is called Ribet constant. Okay, this value we will discuss later. Okay, so general, this is the first formula that you have to remember. Okay, energy at certain energy level is equal to negative RH 1 over n square. Okay, third postulate, no energy is absorbed or released when the electron circulate in an orbit. So means that now let's say the electron is moving to here. Okay, as long as the electron is at the second shell, no matter it is at the top, at the left side, at the bottom, or at the right side, the energy are still the same as long as they are in the same energy level. Okay, next, the last postulate, energy will only emitted or absorbed when electron change from one energy level to another. Okay, so maybe you say we make a story a bit. Let's say the electron at the second shell is very boring already. So the electron might want to go to fourth shell. So from n equal to 2 to n equal to 4, so means that they are changing the energy level. So at this moment, the electron need to absorb energy. Okay, if the electron wants to go to higher energy level. However, if the electron at the second shell want to move to first shell, so now the electron will need to release energy if the electron wants to go to lower energy level. Okay, so normally I will ask students try to remember when you are going up to a staircase because you need more energy, so absorb energy. Okay, so these are the 4 postulates that's suggested by Bohr, at where you need to remember these 4 postulates, but actually they are under CS C1 and C2. Okay, but here one formula that you need to remember is this formula. En equal to negative RH 1 over n squared. The n here is represent orbit, energy level, or shells. Okay, next question. Does null Bohr indicate whether the electrons are randomly distributed? Okay, so if you still remember the reminder that I mentioned with you just now, we always have to remember the formula En equal to negative RH 1 over n squared. So this formula let us know that the energy of the electrons is fixed. So means that as long as it is at the certain energy level, the energy is fixed. Okay, so that's why here we will say that the electrons are not randomly distributed, but they are arranged in series of orbits. Means that can be at first shell, second shell, third shell, fourth shell, and so on. Okay, so each orbit will have a different energy level. Okay, now we are in question number 2a. Explain the difference between ground state and excited state. So I believe when you look at the terms ground, so you will know that it is at lower state, lower energy level, and excited state, that means is higher energy level. Okay, so let's look at the answer here. The ground state is the most stable and the lowest energy state of an atom, while the excited state is the state that has higher energy than the ground state. So let's look at the structure of an atom again. So in the middle here, this is the nucleus. Okay, so let's say we have electron A, electron B, and electron C. So I can say that the ground state for electron A is n equal to 1, while for B is n equal to 2, and C is n equal to 3. Okay, so again, just want to remind, ground state refers to the energy level in which the electrons have their lowest energy. And where it is not necessary to be n equal to 1, the ground state for each electron can be different. However, let's say we have the electron D, so the ground state for electron D will be n equal to 1. So means that ground state is the original energy level that occupied by that electron or by certain electron. However, let's say now the electron D is excited to here. So now we can say that the excited state for electron D is n equal to 3. So refer back to the definition, and the excited state always refer to energy level where it's higher than the ground state. So I hope you can differentiate between ground state and also excited state. Okay, let's continue with question number 2b. Describe the formation of line spectrum of hydrogen atom. So basically, this will be the combination of the last two postulates in the Bohr's atomic model that we discussed in question number 1. Okay, so hydrogen atom will absorb the energy and then excited to higher energy level. So this is the third postulate. Okay, and then do keep in mind that at excited state, the electron is unstable. Okay, so then next what will happen to the electron? They will fall back to a lower energy level. Okay, so this is the fourth postulate. When the electron fall back to a lower energy level, they will emit the energy, okay, in form of photon. Okay, this is what we learned previous. So this photon basically is particles that carry light. Okay, so and then we carry the light, so will be with specific wavelength and frequency. Okay, it may be a bit difficult for you to imagine if with the words only. So now let's look at this diagram. So you imagine actually now there is, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 13 electrons at different energy level, and then all these 13 electrons are considered at excited state. So if you still remember, when they are at the excited state, the electrons are unstable. So at one moment, they will fall back to lower energy level. But when they fall back to lower energy level, if you still remember, it doesn't necessarily mean n equal to 1. Some of the electrons will drop to n equal to 1, some of them drop n equal to 2, and some of them drop into n equal to 4 and 3. Okay, so different electrons, they will fall back to different energy level, but confirm it is lower than their excited state. So again, every electron when they fall down, they will produce, or they are going to release, they are going to release the photon. So and then each photon will have specific wavelength. Okay, this is the symbol to represent wavelength, and also the energy, okay, or frequency. Okay, so then we will continue with the next diagram. Okay, just now the diagram, it shows that is the structure of an atom. So how about now if we transform the structure of the atom in the energy level diagram. Okay, this one we call it energy level diagram. The so-called y-axis here is the energy, and then the so-called x-axis here we will see n equal to 1, 2, 3, 4 until infinity. This is the meaning of energy level. Okay, so the x-axis try to represent the energy level. Okay, so just now we say some of the electron drop to n equal to 1, some of them drop to n equal to 2, and then 3, and also 4. Okay, so these are the one. If we transform them into the energy level diagram, this is what we can see. Okay, then the next one. Every electron, when they drop to n equal to 1, the phi F here is represent final, while the I here is represent initial. No matter the electron, when it is at the excited, it is at which energy level, but as long as it falls to n equal to 1, the electron or the line, we consider the line is produced in Lyman series. Okay, where n equal to 2 is Balmer series, n equal to 3 Paschen series. When they fall to n equal to 4 Brackett series, and when the electron fall to the n equal to 5, we call this one p-fun series. Okay, and then because of each electron going to release energy or photon with specific wavelength, and then they will be in a spectrum region. Okay, different wavelength will show us in different region. So those fall into the n equal to 1 and form Lyman series actually is other UV ultraviolet region. Okay, so that's why if the electron fall to n equal to 1, basically we cannot see the electron. Okay, but if the electron is dropped n equal to 2, so this is the visible region, but for sure we are not seeing the electron. We can see the color, because if you still remember just now we say that when the electron fall to the lower energy level, they're going to release photon. Photon is the particles that carry the light. So that means there is cahaya. So cahaya tu boleh ada berbagai warna. Okay, so warna itu, if we can see the color, that means the rainbow color. So we consider that one is visible region. While if the electron is fall to n equal to 3, 4, and 5, okay, we consider all these three series are in infrared region. Okay, let's proceed to tutorial question 3a. But if you still remember question 2b that we discussed just now and we do the comparison, you will notice basically these two questions are quite similar. Only for question 3a, there is specific mention of Balmer series. Still remember, if Balmer series means that the electron will drop to where? Yes, very good. The electron will drop to n equal to 2. And then the region is visible region. Okay, so how are we going to answer this question? Okay, basically, if you look at here, they still the same. Because of this is formation of line spectrum. Okay, so like just now we mentioned, we will combine postulate, the last two postulate. So again, the electron will absorb the energy and then excited at the higher energy level. So at excited state, the electrons are unstable and then they will fall back to lower energy level. But because of this question have mentioned about Bohr series, so we have to specify that the lower energy level is referred to n equal to 2, and then the energy also emitted in form of photon with specific wavelength and also frequency. Okay, so basically these two are similar. So maybe sometimes in the question they may change the Bohr series to Lyman series. Okay, then you will mention that this one is n equal to 1. Or they maybe didn't say Lyman series, but they let us know is UV region. So if you know that UV region is referred to Lyman series means that the electron will fall to n equal to 1. Let's learn how to draw the energy level diagram. So this energy level diagram basically has the so-called y-axis, which E is represent energy here. And then we convert all the value, actually is based on the standard form, exponent negative 18. And then the unit for the energy is joule. And then all this is represent the energy for one atom or one electron only. Okay, then we are going to draw the horizontal line to represent the energy level from from n equal to 1 until n equal to infinity. Okay, so let's go through here. At the ground state, if you still remember, n equal to 1 can refer to ground state. Force of attraction to the nucleus towards electron is the strongest. So I believe all of you are agree. Okay, because they are close to the nucleus. In the nucleus, there are proton. Okay, so when the energy level is getting higher, attraction of nucleus towards electron will become weaker. So that's why you can see the value here actually is become more and more positive until one moment at the highest energy level at where we represent it by n equal to infinity, the force of attraction nucleus toward electron is almost or near to 0. So how we know the value for here, negative 2.18, negative 0.545? Don't forget, here we have the exponent negative 18. Basically, we are based on this formula. Okay, this formula is the second postulate in Bohr's atomic structure. Okay, so at where, if you still remember, what the second postulate state that energy of the electron at every energy level is quantized, is fixed. So means that as long as the electron is at n equal to 1, the energy is always negative 2.18 exponent 18. In this slide, you are going to learn the difference between energy level diagram and also line spectrum. Okay, so means that on top of the slide is showing energy level diagram, while at the bottom here is showing the line spectrum. So before we continue, let's do a reminding. Okay, for the vertical line is represent the energy of each energy level, which are represented by horizontal line. At the same time, you will notice the gap between two energy level is getting closer and closer up to n equal to infinity. And most of the time, n equal to infinity always is a bow line. Okay, why the gap is getting closer and closer, we have discussed before. So I will not repeat again. And then next, we can see that there is a word Lyman series. So from this word Lyman, we all also again already know that means that the electron will drop from drop from higher energy level to n equal to 1. Okay, so let's say there is one electron from n equal to 2 drop to n equal to 1. So we know when the electron is dropped, they will release energy. And then the energy is in form of photon, which means they have light particles. So at where you can measure either wavelength or energy. Okay, so this line produced when the electron is dropping from n equal to 2 to n equal to 1. While let's say there is another electron drop from n equal to 3 to n equal to 1, there will be another line. If there is another electron drop from 4 to 1, will produce a line again. So n5 to n equal to 1 also will produce a line. So it means that every time there is one electron dropping, they will produce one line. So if you have 10 electrons are dropping, so means that in the line spectrum, supposedly will has 10 line. Okay, so just a very quick conclusion. The energy level diagram is used to show the transition. Transition is mean the movement of electron from which energy level to which energy level. While basically the line spectrum is used to show the wavelength or the energy of the electron that dropping. So later we will discuss about the calculation. So basically these are the difference between the line spectrum, the line spectrum with the energy level diagram. Beside line spectrum, there is continuous spectrum as well. Now, let's see the difference between them. There are gaps between the line as follow for line spectrum, while there is no gap observed in continuous spectrum, such as rainbow. you can only see in general there are 7 colors, but you can't see there are 7 lines. This is because they consist all wavelength in a range, while each line in the line spectrum is come with specific wavelength. Now let's continue with the tutorial question number 3 to differentiate line spectrum and also continuous spectrum, and then give an example for each of the spectrum. So I think basically just now we already discussed the difference. So one of the difference between continuous spectrum is all the wavelength of the line are present for continuous, while for the line spectrum, there is a discrete of line with certain wavelength only. So example of the continuous spectrum are the sunlight or light from the bulb. While for the line spectrum, it's very easy. It's the emission spectrum of hydrogen atom. Okay, next question 5a. State the disadvantage of Ribot equation. So do keep in mind that Ribot equation only can explain atoms or ion with 1 electron. Okay, so this is why so far always we can see in the question, like you will notice they always say hydrogen atom, because hydrogen is the only element that with 1 electron only. Okay, but in reality there is a lot of the element has more than 1 electron. Okay, so that's why Bohr's postulate only as the reference. Okay, so here this is the advantage. Okay, Ribot equation fail when applied to atom or ion with more than 1 electron. So in principle, it only applies to the hydrogen, like what I mentioned, with only 1 electron. Okay, so second part of the question, they ask us to give 2 ions that can be used with this equation. So you just need to make sure you can give any ion as long as that ion is contain 1 electron only. So for example, lithium have 3 electrons, but once they already donate 2 electrons, because 2 plus, so means that they only left 1 electron. Okay, same case to the beryllium. They has 4 electrons. So after 4 electron, so after donate 3 electron, okay, so beryllium 3 plus only left 1 electron. Okay, same case to the helium plus. Helium has 2 electrons, so now after donate 1 electron, left 1 only. Okay, this is the end of this video. So basically we already discussed question 1, question 2, question 3, and question 5b of the tutorial question, which all these mainly are fall in C1 and C2 according to CS. Okay, question 4 and so question 5b involve calculation, so at where we will discuss in next video. Thank you.